Okay, so what is asked in this question from the first chapter of Sakurai is this, that there is a beam of silver atom and that is created from this oven which has a temperature of 1000 degrees centigrade, and it selects some particular atom which is near the mean thermal distribution. So we know the velocity, we know the temperature, we can actually find the velocity from that. So this is basically the Stern Gulf and how we are going to see this. So this is an oven, and then this beam of atom is moving through 1 meter of long magnetic field with a vertical gradient of 10 teslas per meter. So there is a magnet here. It's north, there is south, and this distance they are traveling about 1 meter, and this is now images on a screen 1 meter downstream of the end of the magnet. So after passing through 1 meter length of this magnet, they are subjected to a screen. Now they are assuming that silver atom has a spin half with a magnetic moment of 1 Bohr magneton. Find the separation distance in millimeters of the two states on the screen. So what they are asking us this, that what Stern and Gerlach find out, that there is a beam separation which we were calling as the spin up and spin down. So there is some intensity here, some intensity here. What we are interested in finding is this aspect, right? Okay, so what do we know from the information given? So we know the temperature, that is 1000 degrees centigrade, or in terms of Kelvin, into 73 Kelvin. Then there is a magnetic field gradient. So I would write this as B by Lz, which is 1 Tesla per meter. And then there is, okay, so this is the direction Z. Then this distance, this is 1 meter. So the distance, let's say x is equals to 1 meter. Okay, that's it. And we know the speed velocity vrms, which is given by this, by m. Okay, so these are the details that we know. So what is the first thing that we should find? So from the diagram we can understand that when these atoms are moving through this part, they are experiencing some force. So how do we find this force? So when there is object which contains some finite amount of magnetic moment and there is a magnetic field present, there is some kind of interaction energy. And how do we find this? In our case, this is only the Z part. The magnetic field is along only the Z, so we can write this as minus mu Z bz. So the force is, as we know, negative gradient of u. So that will give me this. So the numerical value of mu z is given as this, which is roughly around 9.27 joules per Tesla. Okay. So we know the force now. So from the force, what can we find next? We need to find the distance. So how do we find the distance? So since there is force on these atoms, they will be experiencing some acceleration. How do we find acceleration? It is the force z divided by their mass. Force is, you know, the mass. So this is the acceleration, and okay, so there is something that we can write about distance. Distance d is equals to, we know that, and we say that v0, the initial velocity is 0, and it half t squared. So this is the distance that will be traveled in the z direction. So we can just write this as delta z, which is 1 half at square. Now we are also interested in how much time it took to traverse the horizontal direction. So that time will be simply x by v, and from that we can write down again deflection in z direction as 1 by 2 a. So notice something here, that after the time t in horizontal direction, so after it is traveling with this v rms speed in the horizontal direction, it might, or we say that because after this 1 meter distance is covered, we observe on the screen that there is a splitting. How much splitting? That we know from this delta z. So this amount of time, after this much amount of time it has spent inside a magnetic field gradient, we observe this splitting. So hence we can just plug this back into the delta z part. Okay, and since the deflection is like this, what we are currently looking at is delta z. In reality, the same amount of deflection will be observed here as well. So the final deflection d is 2 times this delta z part. Okay. So the final deflection is 2 delta z is this 1 by 2 a x by v minus all square, and acceleration we know it is so our next task is to find Vrms, which we know is decided by this. Okay, so if we plug in all these values, so this is mass of one silver atom, right? And okay, so yeah, so since we now know the velocity, plug in all the number, get this as your velocity. So all the silver atoms are approximately moving with this much velocity when they are heated to 1000 degrees centigrade. Okay, so just writing the formula again. So mu z, there is magnetic field gradient, distance traveled horizontally squared, this is velocity squared. Yeah, so if we plug in these numbers, what do we get? So it's 9.27 and power minus 24 joules per Tesla. This is the one Bohr magneton. Then this is magnetic field gradient, which is 10 teslas per meter. Then this is 1 meter squared. Mass of silver atoms, kilograms, and the velocity squared. So when you plug in all these numbers, what you get is 0.001749 meters, which is roughly 1.7 mm, right? So what we have established here is nothing but this, that when these atoms are splitting, not splitting but their spin component, this is what we famously call the spin up and spin down. So in the Stern-Gulag experiment, this is roughly the distance between the spin up and spin down components, 1.7 mm.